Good morning. My name is Mr. Van Steen, and I'm a school teacher, fourth grade school teacher at Columbia Crest. Before I became a school teacher, though, I was a mountain guide, and I spent a lot of time on Mount Rainier, and I even wrote a book back in 1999 that I think will give you some evidence that will help you in your discussion on climate. So I want to introduce you to a few glaciers. Let's start by getting rid of me and introducing you to the first glacier. The Tahoma Glacier is this beautiful, massive flow of ice that goes from the top of the mountain all the way to the wooded area below. One of 6 glaciers that does that. When you look at that, you think, wow, that's a lot of ice. Interesting, however, to note that in the early 1800s, this terminus extended a mile down valley. That's quite a bit of glacial recession just in that time. The next glacier is another one of the big 6, the Nisqually, goes from the summit all the way to the Nisqually River, a name I'm sure you recognize. These 2 photos, this first one is at the bridge that crosses the Nisqually up in the park, and it looks down into the what will become the Ashford Valley, right? With all the woods and trees. And this is looking up toward the snout where it is today. I took this picture in 2008. So in the 1800s, the ice of the Nisqually was 600 feet beyond the bridge, somewhere in this area, and the ice was thick to the rim, all the way up here. So you can see a lot of ice loss. Now, there's something else I want to throw into the equation for you guys to discuss, and that is that Gibraltar Rock is this massive rock that sits just up above and to the right of the Nisqually. So the Gibraltar is right up in here, and it's constantly collapsing and throwing a blanket of debris and rock and boulders down over the glacier, so that when you look at the lower reaches of the glacier, you still get the thick ice and the crevasses, these big slots in the ice, but you have an insulating cover of rock that keeps recession to a certain degree at bay. Is it climate change, or is it insulation by that rockfall? The Carbon Glacier is this gorgeous, thick, almost primeval looking glacier on the north side of the mountain, and it being on the north and it being in this huge cirque, the sun doesn't shine there very often, so you see massive amounts of snow, much more so than anywhere else on the mountain. Here I am climbing some rock, but even when when we're on the north side of the mountain, we're constantly in awe of and careful of these huge hanging amounts of ice everywhere. It is a place where this is a September climb, even the latest part of summer, thick ice still abounds. Now, this is my story, probably the shortest term story. I started climbing on Mount Rainier in 1985, and I noticed on the southwest side of the mountain there were these interglaciers or pocket glaciers or remnant glaciers. When you look this up, they are glaciers by the names of Servant and Paradise and Willie Walkus, and they look just like permanent snowfields, except they're pretty icy. Can't really kick your boot into these very easily. Look at this photo. Roughly the same area. The one on the left was in 2001. The one on the right was in 2010 or so. Seasonal change here or climate change? What's going on? On the right-hand side, I'm sitting on a little rock within an ice cave. Now, these ice caves have all but disappeared when I sat here in the late 80s, early 90s. I'm not sure when this picture was. The water underneath the glacier carves out these ice caves. Even back in the late 80s and early 90s, we saw a collapse of these caves. If you go out there today, you guys, you will not see anything that looks at all like an ice cave. You'll see just a patch of ice, or a dry field. A couple of other ice caves here that I'm exploring. My secret as to where they are, but maybe one day you'll find them. Anyway, I hope I've given you some evidence, historical evidence, as well as some anecdotal stories to discuss. Good luck on your assignment. Thanks so much. Bye.